Assalamu alaikum. In this lecture we are going to study the need of surge impedance loading, that why do we have to calculate the surge impedance loading of a line, and what is the purpose of it being calculated, and what is its usage when we are designing the transmission line. So typically for transmission lines, for example, we have a 230 kilovolt line. The surge impedance loading that is calculated for this voltage level is 150 megawatt. So as per the last lecture, if you are putting more load than 150 megawatt, then there will be a voltage drop at the end of the transmission line, and if it is less than 150 megawatt, then there will be a voltage rise that is seen at the end of the transmission line. Then for example, if we have 765 kilovolt line, then the surge impedance loading will go up to 2000 megawatt. These are the values for the surge impedance loading for 230 kilovolt value and 765 kilovolt voltage value for the transmission line. Similarly, for the surge impedance values for overhead line and cable are, overhead line we have the value of surge impedance ranging from 400 to 600 ohms dependent on the type of the line, and for the cables the value is 40 ohms. Now the question arises that why do we have to make the calculation related to SIL? So there are three usage of SIL calculation. The first one is that we can calculate the loadability of the line. Then we can also calculate the number of circuits. And lastly, we can size the surge arrestor. Starting from the first point, which is loadability of the line. I will explain this with the help of an example. So assume that we have a short transmission line, and short transmission line is the one which has length less than 80 kilometer, and the voltage of the line is 110 kilovolt. Now we have to calculate the loadability of the line, that how much load can we put on this transmission line. And let's assume the SIL value can be between 1.2 to 1.5 times SIL. And to calculate the loading, it will be 1.5 times into SIL. So I am assuming the worst case scenario, that the loading can be 50 times more than the actual SIL value. And at the SIL value, surge impedance loading value, the voltage has a straight line. The voltage profile has a straight line. So whatever the voltage is at the sending end will be at the receiving end. So in this case, I am assuming that the loading can be up to 1.5 times the SIL value. And from the previous calculation, we know that SIL is equal to receiving end voltage divided by surge impedance. Receiving end voltage square divided by surge impedance. So this will become 1.5 into receiving end voltage is 110 kilovolt square divided by 400. So this will give you the value 45 megawatt. So if you have to decide the loadability of the line, like in this case, with the voltage value for the transmission line was 110 kilovolt, the loading can go up to 1.5 times the SIL value. So the loading of this transmission line will be 45 megawatt. Then the second thing is that we can also calculate that how many circuits can be used in a transmission line, so we can make a decision on a number of circuits. Now suppose we have to transmit 100 megawatt power at 220 volt, sorry, kilovolt. Now the surge impedance loading will be equal to 220 k square divided by Zs, and for this Zs we can have any of the values between 400 to 600. So I'm assuming that it is equal to 400 ohms if it is a overhead transmission line, but if it is cable you will use it 40 ohms. So the surge impedance loading value for this transmission line will be equal to 121 megawatt. So the capacity of the line is enough, so you can use a single circuit. But if the SIL value is greater than 121 megawatt for this case, then what will happen? Then you have to use more than one circuit. So it should be a double circuit line if the loading is, for example, 150 megawatt at 220 kilovolt, right? So in this case you will use a single circuit. And similarly for the sizing of the surge arrestor, you will use the surge impedance loading value. So these are the few aspects that are covered in the design of transmission line while using the surge impedance loading calculations. That's all for this lecture.